Yes, scholars, once again, let us continue with lesson of biology, of course, for advanced scholars. Of course, I'm in a class for advanced biology learners in senior 5, senior 6. I think now we can go on. Last time we were dealing with them with the dihybrid cross. And so, of course, here today we are going to begin looking at the exceptions to Mendel's laws of inheritance. Exceptions to Mendelian inheritance. Mendelian inheritance. Exceptions to Mendelian inheritance. So, we have inheritance which doesn't obey Mendel's principles of inheritance. So, that's what we call the exceptions to Mendelian inheritance, or the exceptions to Mendel's principles. So now, at the moment, the exceptions to Mendel's inheritance are many, but we shall be looking at one by one. So, some of these include, one is linkage. The other one is epistasis. The other one is lithogenes. The other one is complementary genes. This is the letter L. Complementary genes. Next is inheritance, or we call it inheritance of comb shape. Inheritance of comb shape. In false. Inheritance of comb shape in false. Then another one. So, what I have so far outlined here is what we call inheritance to Mendelian inheritance. They are not in agreement with the principles of Mendel. One is linkage, we have epistasis, lithogenes, complementary genes, inheritance of comb shape, and then that is inheritance of comb shape in false. False are also called buds. They are also called buds. Then we have what we call multiple alleles. All these are exceptions to Mendel's principles. So now today we shall deal with linkage. We shall deal with inheritance evolving linkage. So that's what we shall deal with today. So let me write linkage. Now, briefly, linkage is whereby genes that determine different characters are located on the same chromosome. Linkage is whereby genes that determine different characters are located on the same chromosome at different loci. That's what we call linkage. And we say is whereby genes that determine different characters are located or carried on the same chromosome. On the same chromosome. Whereby genes that determine different characters are located or carried on the same chromosome. That's what we call linkage. That is the meaning of linkage. So now, when we talk about linkage, this one now brings us to what we call linked genes. Linked genes. And I will say, our genes that determine different characters, or characteristics, genes that determine different characters, but located genes that determine different characters found on the same chromosome. On the same chromosome. Genes that determine different characters found on the same chromosome, but at different loci. So, those are linked genes. A gene that determine different characters found on the same chromosome but at different loci. So, we can also say linkage is whereby genes that determine different characters are located on the same chromosome at different loci. At different loci or positions. So, when you are explaining the meaning of linked genes or the meaning of linkage, there are three conditions that must be satisfied. One is that those genes determine different characters. That is one. Two, they are located or carried on the same chromosome. And then three, they are found at different loci or positions on the chromosome. Those are the three conditions that must be satisfied. And therefore, Linked genes are genes that determine different characters found on the same chromosome but at different loci. Those are what we call linked genes. Suppose I have a chromosome. If I assume this is a chromosome with 3 genes at different positions, as shown on the board. If I have a chromosome with 3 genes, A, B, C, what can we say? We can say that genes A, B, and C are linked genes. Are linked genes because they are carried on the same chromosome. So genes A, B, and C are linked genes because they are carried on the same chromosome. So now, this one also now brings us to what we call linked characters. I can talk about linked characters. So, these ones, they are characters which are determined by genes that are located on the same chromosome but found at different loci. Characters determined by genes located on the same chromosome but at different loci. Characters which are determined by genes which are determined by genes carried on the same chromosome but at different loci. Determined by genes carried on the same chromosome at different loci. Loci is the plural, is the singular of the word locus. So the singular is locus and plural is loci. So loci, or the term locus, describes position of a gene on a chromosome. Now, linked genes located on the same chromosome form what we call a linkage group. They form a linkage group on the chromosome, and of course, those genes are likely to be inherited together. They are transmitted together, or they are inherited together. So, I can say that linked genes pass into a gametic cell. Linked genes pass into a gametic cell during meiosis. pass into a gametic cell during meiosis. During meiosis. What does it mean? It means that linked genes are normally inherited together. So they pass into a gamete and separated during meiosis. So we say they are inherited together. Another thing is that linked genes on a chromosome. Linked genes on a chromosome form a linkage group. Form a linkage group. So genes located on the same chromosome form what we call a linkage group. And so we can say a linkage group is a group of genes on the same chromosome, and those genes are inherited together during transmission of genes. They are inherited together.